welcome back to my channel, The Math Professor. Today we are discussing a trigonometric identities question, and the question is, for what values of x and y, the equation sec² equals 4xy divided by x plus y squared possible? At first, this question might look tricky, but as always, we'll use a step-by-step approach to solve this. First, we know that sec² is 1 plus tan² theta. The right-hand side of the equation is 1 plus tan square, and tan square will have a value which is either 0 or more than 0. That means we can write sec² will always be greater than or equal to 1. And we also know that for any two numbers x and y, their arithmetic mean is greater than or equal to their geometric mean. And arithmetic mean between two numbers is x plus y over 2. It is greater than their geometric mean, which is square root of xy. If you square both sides, you'll get x plus y whole square over 4 greater than or equal to xy. Or I can say 4xy over x plus y whole square is less than or equal to 1. So you have one equation where you have sec² is greater than or equal to 1, and 4xy over x plus y squared is less than or equal to 1. There is only one possibility when sec² is equal to 4xy over x plus y squared by using 1 and 2. That is when 4xy over x plus y whole square equals 1. And if you simplify this, you'll get x plus y whole square equals 4xy, or x squared plus y squared plus 2xy minus 4xy equals 0. If you simplify it further, you'll get x squared plus y squared minus 2xy equals 0, which can be written as x minus y whole square equals 0. That means x is equal to y, where x and y both belong to positive real numbers. So sec² can be equal to 4xy over x plus y whole square when x is equal to y. If you found this video helpful, please share it with your friends and subscribe my channel. Thank you.